Welcome to the NHERI SimCenter's training in regional simulations. Today's training will be provided by Steve Gavrilovich, who is a postdoctoral scholar at UC Berkeley and the lead developer for the Regional Resilience Determination Tool, or R2D Tool. Steve, if you would go ahead and share your screen, I invite you to begin.
Okay, thank you. Okay, great. So hopefully everyone can see my presentation now. Hi, everyone, and thank you for coming. My name is Steven Gavrilovich, or Steve, and I'm a postdoctoral scholar and software developer at the University of California, Berkeley. And today I'm excited to talk about the Regional Resilience Determination Tool, or the R2D tool developed here at the SimCenter, which stands for the Center for Computational Modeling and Simulation. And we're part of Niri and funded by the NSF, for the National Science Foundation. So the long-term vision in R2D is to be able to simulate an entire region with various types of infrastructure subjected to different types of hazards. Right now we support buildings and earthquakes. That's good for a majority of you here. But coming up real quick, we'll be able to analyze lifeline networks such as natural gas pipelines. And also coming down the pipeline, we have hurricane hazards, which in fact, today I'm going to give a little sneak peek, show you where we are with the hurricane hazards and what we have coming down the pipeline. The final goal, of course, is to be able to simulate recovery of a region. And of course, that region should have multiple assets and be able to be subject to multiple hazards along the way. So here's an outline of today's training session. First, I'm going to go over the installation and setup of R2D. I'm going to provide an introduction to the SimCenter, who we are and what we do. Then there'll be an overview of the R2D tool, just a real general overview to show what it can do, what its capabilities are. Then I'm going to go over each pane to go through the settings and inputs. You could wrap your head around how it looks to run an analysis, to run a hazard simulation. And the next bullet item here is, of course, hazard simulation. Important functionality in R2D is to be able to simulate different types of hazards. So we'll go over how to simulate earthquake hazards and also hurricane hazards. Next, I'm going to show you how to run analyses on your machine locally and also remotely on the design-safe supercomputer. Then we'll go over the results and post-processing capabilities of R2D, where you can find the results, how you could view them on the geographic information system, the GIS visualization pane. And then I'll have a live demonstration, and we'll go through an example that should be interesting for the structural engineers here. Finally, I'll end with a Q&A, questions and answers, and hopefully we'll be able to answer some of the questions you may have. So to get started, we need to download R2D from DesignSafe. You can go to this link here, but the easiest is to Google SimCenter R2D tool, and one of the first few links that pop up should be this web page. And on the right-hand side of that web page, there are links to download the app. Now, a new update was released on Tuesday, so if anyone has installed R2D before that, I would recommend that they go and download the newest version if you want to follow along, of course. You can also, on this page, you can also view the documentation. So the documentation is all online. You can view it at this link. And finally here, you could access the SimCenter forums. I note that this is the first release of R2D. There may be bumps and hiccups along the road. So I'd appreciate it if you can report any bugs or questions on the forum. And also being the first release, please post any feature requests you may have so that, of course, we could provide a program that will be helpful to you. Once you download the app, depending on what operating system you have, we support both Windows and Mac. So for Windows, you're going to download a zip file. You're going to extract the zip somewhere onto your computer. And all you have to do is double click on the r2d.exe, the executable. And this is how the icon looks right here. For Mac, it's a little bit more involved. You'll have to download the DMG file, open it, drag that icon somewhere onto your local computer to install it. So let's say your desktop or your documents. And once there, then you'll have to go and install Python 3.8. So we only support version Python 3.8 for now. and our backend runs in Python. So you'll need this to be able to run any analysis. And I recommend you go to python.org to download the Python 3.8. Of course, it's only for Mac. In the Windows version, Python comes bundled in the executable, but because of security reasons, Mac won't allow that. And you need to install SimCenter dependencies, so different Python packages that we require in the workflow. And that's a one-line installation here. So it's pip install NHERI-SimCenter. While everyone's getting set up, I'll talk a little bit about the SimCenter and who we are, and what we do. So at the SimCenter, we develop and integrate tools and methods to better understand and mitigate the effects of natural hazards through advanced computational simulation. A key takeaway here is that the SimCenter specializes in computational simulation in natural hazards. So we put a lot of effort into creating these test beds to showcase the computational simulation that we do. Here on the bottom left corner is the San Francisco Bay Area test bed, so over 1.8 million buildings, subject to a magnitude 7 Hayward scenario earthquake. On the right is our Atlantic City, New Jersey test bed. Here's about 20,000 buildings subject to a Category 5 hurricane. And of course, one of these test beds could be a starting point to test out your new algorithm or method that you develop in your research. And in addition to test beds, we have a lot of examples that come bundled with our programs, which I will go over in this presentation. Here's an overview of the Niri facilities. So as I mentioned, SimCenter is a part of Niri, which stands for Natural Hazards Engineering Research Infrastructure. The SimCenter is up here at UC Berkeley. And also important in this presentation will be the Design Safe cyber infrastructure, which is located at the University of Texas in Austin. This is a high performance supercomputer where we run a lot of these high complexity regional simulation. Apart from those two, there's many other facilities in the Niri network. They're mostly experimental laboratories such as shake tables, wind tunnels, wave flumes, and that sort of thing. But the SimCenter really specializes in computational simulation. So we develop open source and extensible tools for researchers and connect them with high performance computing resources to facilitate high fidelity simulations and uncertainty quantification. The key there is that our tools are extensible. You can add to them, and they can be run in high performance computing environments, which is of course important in these types of regional analyses. And we like to represent our software as these little puzzle pieces here with a preprocessor, post-processor. And the idea is you combine these puzzles to create a scientific workflow that can be used to solve very complex problems. You'll notice that uncertainty quantification plays a big role in all of these apps as well. Today I'm going to be talking about the front end user interface, which is the R2D tool. And this calls the backend, which is rWHALE. So rWHALE stands for Regional Workflow for Hazard and Loss Estimation. And the front end assembles the analyses, the input files. It lets you view what's going on, helps you create these input files to send to the backend. The backend crunches the numbers and then sends the results back to the front end for post-processing and for visualization. And this is the overview of the SimCenter computational framework. At the bottom, we have the different databases for, say, damage and loss, modeling, and building inventory or asset inventory. We also have applications to develop these databases, such as BRAILS, which stands for Building Recognition Using AI at Large Scale. And as I mentioned before, uncertainty quantification is important. So we have QuoFam and different algorithms which control how uncertainty is propagated through the workflow. One step up, we have various apps to assess how different hazards impact the built environment, such as earthquakes, wind, and hydro, water. And you'll notice how each one has UQ appended to the end of the name. One more step up is PVE, or Performance-Based Engineering app. And it takes the responses from these different apps below, which are assets subjected to various hazards, and it translates those responses into damage and losses. Finally, at the very top sits R2D, which we're going to talk about today. And R2D generalizes the workflow to analyze entire regions with multiple assets, multiple hazards. So in a nutshell, R2D leverages all the hard work that's gone into creating these programs over the last 4 or 5 years at the SimCenter. And with R2D, you could produce region-wide results. A quick note, next week, there'll be another SimCenter tool training workshop. That's on May 24th and 25th at the same time. And this will be training in uncertainty quantification. As natural hazards engineers, we all know how important uncertainty quantification is. You can't predict the future. So I recommend you attend this workshop as well. It'll be worth your time. Also, there's a new release of HydroUQ on the horizon, which HydroUQ is an app to assess the impacts of tsunami and storm surge hazards on infrastructure. So look out for this one. It's coming really soon as well. So a common thread across all SimCenter applications is the ability to harness high performance computational resources at TAC, which stands for the Texas Advanced Computing Center. This is you, a Niri user. You go to Design Safe, you download different apps, and there's 2 options to run the simulations. The one is on your local Windows or Mac computer. So if they're small simulations, you could run them directly on your laptop. But for computationally expensive jobs, which many times is the case for regional scale analyses, the users can run jobs on the high performance cloud computer. And in this presentation, I will provide instructions and guidance on how to do both. There's also other online cloud resources that we get app information from, such as the PRNG OS2 database. In R2D, it pulls ground motion records to create earthquake scenarios. And there's also the data depot at Design Safe where we store our apps. So you don't have to upload any apps. Everything is sitting there. There should be a one-to-one match between the app you're running on the computer and the one that's sitting at Design Safe. All you have to do is submit the job. And I will go over how to do that. Here I want to provide a high-level introduction of what I'm going to go through today related to R2D. Hopefully by now you might have it installed. If not, don't worry. First, I'm going to provide an overview of the user interface, then the different inputs and settings to get you up and running to run analysis and also to simulate different hazards. I will go over the earthquake hazard simulation app, how we can create a grid of earthquake ground motion. Then I'll go over the hurricane hazard simulation app, which is in development, but coming soon. So I'll show you how far along we are and what we have. I'll then go over how to run these analyses locally or remotely. And finally, how we can view the results in a GIS system and also go through where you could find the raw CSV files if you want to do your own post-processing. So the idea of R2D is to easily set up and run these applications and get the results in a convenient location, both locally and remotely. So the first thing you'll see when you open R2D is the main user interface. Starting at the top right is a login button, and this is where you'll want to go if you want to log into Design Safe to run these jobs remotely. Directly below that, we got the input panel, and to the left of that, we got the panel selection ribbon. And when you click on these different apps, and I'll explain what each one of these acronyms mean, as you click through here, the input panel changes to reflect whatever app you're currently in. At the bottom, we got buttons to run. We got the buttons to run locally, a button to run things remotely, and then this button to get the remote job manager dialog where you can access all the remote jobs that you have running or finished at Design Safe. And finally, there's the exit button if you want to conveniently exit the program. So next I'm going to describe the menu bar, and within this menu bar there's some pretty important functionality buried in it. So this is the menu bar on a Mac. It will look slightly different on a Windows computer. So the first R2D menu here is where you access the preferences, which I'll get into in a subsequent slide. The file menu is typical like most other programs. You could open an input file, you could save the current state of R2D. So say you've been setting up analysis, you could save that and load it again in the future, come back to it. Under the edit menu option, you could clear everything. So this resets R2D to a clear state. It clears all the inputs and lets you start afresh. In the view menu bar, which I'll go over in a few slides here, you could see the status dialog, which all the output from R2D gets piped to the status dialog, and you could make it appear or disappear at will. Then there's a results menu bar where we could load the results. You don't have to run an analysis every time to view the results. You can go directly here, click on load results, and point it to the results folder, and it will load the results that you've run previously. In the examples menu bar, there's a manage examples action or button that when you click on, the examples dialog pops up, and it lets you download and manage or delete your examples that you have. You can imagine with R2D and these regional examples, it can be quite large, so we don't ship them with the program, but I will go over how you can download and install with just a few clicks all the examples we have sitting on the cloud. The important one is a help menu. Here we have access to the user manual. So if you click on this menu item, your internet browser will open and it'll take you directly to the user manual for R2D. And the same thing here, if you click submit bug and feature request, it'll take you to the SimCenter forum for R2D. So you can submit a bug request. You could say, hey, I want this feature, and we'll respond pretty quickly and hopefully get you running. Now here, this is important for Mac users. This is the preference pane. And when you open this, it tells you what Python R2D is using. It tells you which application, which OpenSeas R2D is using, which Dakota, which I will explain what Dakota is in a few slides here. But R2D typically comes bundled with OpenSeas, Dakota, and our backend applications. If you want to create your own backend applications or use your own version of OpenSeas, this is where you would change that in the preferences. As I mentioned previously, in macOS, Python doesn't come bundled with application, so you have to install it yourself. And you have to point, R2D has to know where it is. So you'll have to point to it here. You'll have to find it on your system. And typically, if you install it from python.org, it will be at library, frameworks, python.frameworks version, and you want to point it to the Python 3 executable sitting in the bin folder. And this is the remote app it's running. So you don't have to do too much playing around here. You can just leave this as is. But if you ever want to know where things are being saved, or if you want to, for example, change where R2D is running these analyses, so you want to set the local jobs directory. By default, it's set in your documents, R2D. But if you want it on your desktop or somewhere else, you can go here and change where the local job directory will be created and where the remote job directory will be created as well. So in the local jobs directory, this is where the input files get created, and this is where you see the results. And in the remote jobs directory, you will just see the results here. So here's the program output dialog. It looks like this. So you can go to View, Show Status Dialog, and this will pop up. Every time R2D receives a message, this will pop up displaying the message, and you could look at any previous messages here as well. If it's bothering you, you can click Close. Don't worry, it won't clear or delete any of the previous text you have here. You can do that by pressing the Clear button. So you could press Close and come back to this, go to View, Show Status Dialog when you're ready to see it again. And if it's getting in the way, you could always press Close and hide it, and again, come back to it anytime you want. Here's the examples manager I was talking about. When you click on Manage Examples, this dialog will appear, and it lets you select different examples. You can just check the examples that you want and click Update, and it will download those examples from the cloud and automatically install them into R2D. So you could come back to the examples menu, and they will be listed below here. If you want to delete them, you just uncheck them and press Update, and those examples will be deleted and they'll no longer be part of R2D. And these examples get stored in the examples folder next to your executable. So if you're in Windows, You got R2D.exe. In that same folder, there would be an examples folder where you will find a folder for each individual example. So that these can be used as a template to help you get started with your own analysis. Each one of these examples showcases a different feature of R2D. And I will go through some of them later on here. So here's the panel selection ribbon that I mentioned previously. And on the right-hand side, we have a legend of what each one of these acronyms stands for. I'll quickly go through it. We have VIS, which stands for visualization. This is where that big GIS visualization pane is. We have GI, which stands for general information. HAS, stands for hazard definition. ASD, which is asset definition. HTA, which is hazard to asset mapping. MOD, which is asset modeling. ANA, which is asset analysis. DL, stands for damage and loss. UQ, stands for uncertainty quantification. RV stands for random variables, and results is where you can see the result at the end of the day. I'm going to go through each one of these panes in the subsequent slides. So this is a visualization pane. This is the first thing that opens when you run R2D. And here's again that big GIS pane where the map gets displayed. And you could change the base map in this combo box here. So by default, it's set to topographic. You can go through and change this to say satellite imagery, street maps, to whatever you really want to get your figures, your presentation or whatnot, or reports. You have different map layers that are right under the combo box. And if you click on a layer, you can turn the visualization, turn that layer on and off. Right next to that, we have the map legend. So as you click on different layers, this legend will change to reflect what components or what visual elements you have in that layer. So if you click on, say, user ground motions, it'll tell you how ground motion grid point looks like. When you click on buildings, it'll tell you how building footprint looks like to give you an idea of what's going on. Right under that is the asset selection, which I'm going to go over in the next slide. But this lets you select assets directly on the GIS map for analysis. This is how that works. The user clicks on the select point button and then zooms in and out on the map, whatever they feel comfortable. And then they click on the map to create this polygon. You see each one of these points is a user selected point. So you could select, one building or two or as many as you want, whole city blocks. You zoom out a bit. And the idea is when you click on the apply selection button, whatever is in this polygon gets added to the selected objects layer. So there's a layer here. It's called selected objects. And in this case, we just added these buildings that are highlighted in yellow here. And you could add pipelines. You could add different types of infrastructure if you don't want to, analyze everything. This gives you a convenient way to visualize where things are and to add them to an analysis easily. And whatever you add here will appear downstream in the asset definition pane, which I'm going to go over. Yeah, and at the end of the day, this allows for parcel level selections. You could go down to single building, select the target the buildings you want to analyze, or you could zoom out and you select whole city blocks. In the general information pane, the user can enter the different analysis metadata, such as analysis name. You can pretty much put anything you want here. It allows you to select the different units. So what units are you working in? Then you could select the type of asset. In your version, only buildings are supported, but I have access to more assets here. And in the future, more and more different types of assets will be added. And then the output settings define the granularity of the output results. So for example, the user has the option of outputting all or some of the engineering demand parameters, intensity measures, and decision variables. And you could output these at each sampling iteration as well. This gives you control over how much data you want in the result. In the hazard definition panel, there's several options for defining hazards. In the current release, what you have, only earthquakes are supported. However, in this presentation, I'm going to go over the hurricane scenario simulation, which is coming up very soon, to show you what we have there. So in the earthquake scenario simulation, this allows a user to create a grid of correlated ground motions over regions. If I go back here, the grid will look something like this. And what happens here is that first we want to define a site. So it could be a point or a grid. I recommend you define a grid. And the information from the earthquake rupture definition and ground motion prediction equation will be used to compute a target response spectra. So at each grid point, or of course spectra if multiple records per site are selected. So on this grid, you could have, say, 1 ground motion or 10 ground motions that are picked for you at each grid point. And then the spectra at different sites is spatially correlated according to the inputs given up here. And then for each site, the target response spectrum or spectra is used to select ground motion records from a ground motion database. And currently only Pier NGA West 2 is supported. And these records get downloaded automatically. You don't have to log in. You don't have to supply your credentials. R2D has direct access to that database to download these records for you. So to define a single location, you go up here in the grid type selection, you click on single location, and then you supply just the latitude and longitude of where you want this point to be, where you want the ground motions to be selected at. And then you also define the number of ground motions you want at that point, so 1 or more. At the grid of locations, and of course, sorry, going back to this number of ground motions, obviously in every analysis, a ground motion is selected randomly. So having multiple ground motions allows for a better description of the uncertainty at a particular site. You should want more than 1 ground motion. So you could sample from different ground motions as you run these analyses, and gives you a better idea of the uncertainty there. Going back to the grid, you'll want to define the latitude and longitude bounds of the grid, and also the discretization. The user can do this manually. However, it's much easier to just select this on the GIS map, and you do that by clicking on this Define Grid on Map button at the very bottom. So clicking on this button opens up a new screen, which will show you the same GIS view you have in the visualization pane, but it will be overlaid with this proposed grid. So users can select these corners to adjust the grid. You can make the grid smaller, larger, and I'll show you how to do this in the demo. And you could also select this red circle. It's a little bit hard to see, but in the center here, to move the grid around, to drag it up and down, left and right. And the idea is you want to have, say, your assets input, and you want to overlay this grid atop of your assets so you have good coverage of all the assets you want to analyze. And if you change the discretization here on the site definition pane, that'll automatically update on this map. So you could close this, change the discretization, open it, and it will reappear in the same position it was before. But the number of divisions will have changed. And you could also move this to the side and play around, and you'll see the grid move and the discretization change as well. So these two are linked, but this just provides a convenient way for the user to go into the GIS map and select where they want their grid of ground motions to be created. So in the earthquake definition panel, you could select either a point source for your rupture, or you could select a rupture forecast. In the point source panel, the users are expected to define the earthquake magnitude, the location where you want the rupture to occur, and the depth of the rupture. And the rupture forecast, you want to have magnitude bounds, so it's the minimum magnitude and the maximum magnitude, and the maximum distance, so how far away do you want to consider faults. And you could also filter down the fault selection according to earthquake name. So if I type in San Andreas, it's going to look at the San Andreas fault. And then you can select the forecast model right here below. And you'll notice that only USURF models are currently available. And USURF stands for Uniform California Earthquake Rupture Forecast. So this is really only useful for now in California. If you try to create this grid somewhere outside of California, you will probably get errors. And on the right-hand side here, you have the ground motion prediction equation that you could select to work in concert with this rupture forecast. I'm here to talk about spatial correlation and also scaling. So inter-event quantifies the deviation of intensities at a specific site given different earthquake realizations, so between events. And you got intra-event, which quantifies the deviation of intensities at different sites given a specific earthquake realization. So it's within a specific earthquake, but at different sites. So you can select the different inter and intra-event correlation models up here. And below that, you can enter the ground motion record scaling bounds. So when you go into ground motion selection, you can scale those records to match your target response vector. Lastly, a user can select the type of intensity measure they want. Say they want spectral acceleration or PGA. If you select spectral acceleration, you'll have a list of periods that you provide, which are used to compute the values for the response vector, and also it's used within the correlation models to interpolate the different correlation coefficients. If you want more information on how this is done, you can go to this link down here. This is created by Quanchi, another postdoc at the SimCenter. And yeah, if you go to this link, it'll take you to the backend source code, which will provide you more detailed information of what's being run and how these inputs are being used to do this ground motion selection. So at the end of the day, as I mentioned, you run the backend script and the output looks kind of like this. So it will select ground motions, it will contact peer, it will download those ground motions, and then it will load them all back into R2D, and it will look something like this. You'll have this ground motion grid with different grid points, and at each grid point, you'll have the ground motions, the station name, and the location. Finally, if you want to access the files, or you want to see where these ground motions are stored, if you clicked on the settings button at the initial pane, it will bring up this dialog you see here. And this dialog has a working directory where this input file will be created to be sent to the backend. It has the input directory. That's where you'll find the input files. This is the base directory, so it'll be, in my case, documents, R2D, local work dir, hazard simulation, ground motions, and then you'll have the directory that contains the inputs, and you'll have the directory that contains the outputs, and the user can, of course, change these. And this is how that looks on a Mac. So if I click on local work dir, hazard simulation, ground motions, okay, I have hurricanes here below. If I click on ground motions, output, it will list the different output files in this folder, and the main one is this event grid file. And at each grid, this essentially lists the grid, and at each grid point, it has a list of these ground motions. And the ground motions here are stored in a JSON format. We call this the SimCenter event format. Okay. Now, users only have to run the earthquake scenario simulation once. Once they create that grid, they could go to that output folder, copy and paste that somewhere else on their computer so it doesn't get overwritten. And now they have access to that grid for importing in the future. And you could import it through this user input ground motion app. So you have to point this input box here to the location of that event grid, that CSV file. And also, if you're storing your ground motions in another folder, you could point it to the path to the folder that contains these ground motions. Now note that the user can load any ground motions, really. Say you have a physics-based ground motion simulation, really fancy, stochastic or synthetic ground motion simulation, where you could take those and translate them into the SimCenter format, which again looks just like this. It's a JSON file, the name, time step, and then the time history listed in a JSON array like this. And you could come back here and load it into R2D. So you don't have to even run the earthquake scenario simulation if you don't want. You can do your own thing and translate it into this SimCenter format, and then you could import it here. And most of everything here is in JSON format, so all our input files, our event files, and output files as well that get fed into the backend. I'm going to talk a bit about the hurricane scenario simulation. This is upcoming. You won't see it on your version of R2D, but it's coming up very soon. And similar to the earthquake scenario simulation, here we create a grid as well, but the grid isn't a ground motion, it's a wind field grid or a storm surge grid. So the first option allows the user to specify a hurricane track, and this is what you see here. It's input it as a CSV file. And this is useful if a user has some specific hurricane scenario in mind, or if you have tracks that are generated by some model, you could plug them in here. And then you specify the landfall location, this little diamond symbol here. And you create your grid. So you go define grid on map, and similar to the earthquake scenario simulation, you could zoom in to where your assets are, you create a grid in the region, and you define some landfall parameters, which is the landing angle of your hurricane, wind speed, gust duration, and so on. And you could click on Run Hurricane Simulation, and it will create a wind field grid wherever you defined it. So in the demo, I will go over this functionality as well. There's also the ability to select a historical hurricane. So here, the NOAA database, or IBTRACS, or International Best Track Archive for Climate Stewardship, comes bundled with R2D. And if you click on Load Database, it'll take a few seconds, and it'll load every hurricane that occurred, I guess, in the last 3 years. And I think it has to be at least some level of strength. Not every little windstorm gets added here. And this allows you to pan through the world to see where you want to run a simulation. You could zoom in. Right here, you could select the hurricane. You can see a selected Hurricane Laura. 2020 has a storm ID. And if you're satisfied with your selection, you could click on Select Hurricane, and it'll take whatever hurricane you selected and download the track. Show the track on the GIS screen. It'll automatically fill in where landfall is, the different parameters at landfall, so you could run a simulation pretty quick. Again, all you have to do is define a grid at the end of the day, and you click Run, and it'll be sent off to the back end. It'll take a little bit of time, but at the end of the day, this grid will be loaded into R2D, and you could select a point, get the latitude, longitude, and all the parameters of that wind field grid will pop up. In this case, we have 3 peak wind speeds. So again, similar to the earthquake simulation, you can specify how many realizations you want at each grid point, or how many earthquake ground motions. In this case, how many times do you want to calculate the peak wind speed? I'm going to take a quick drink of water here. So moving on to asset definition. Here, a user enters a building inventory database. Currently, we only support the import of CSV files, but as I mentioned previously, there will be a database creation tool like Braille's that you'll be able to click on it, define a region on the map, and it will use artificial intelligence to create a building database for that region. To load a CSV file, the user just simply needs to go here, browse, find it, and everything gets loaded automatically. You can also select what type of asset you want to load up here. So you won't see this on your version of R2D, but I have buildings and gas network. So depending on which type of asset I click on, the different import apps will appear here. Now this is buildings. As part of this asset definition pane, we have something called a subset selection. So this lists the IDs. So if you go down this first column, these are building IDs, followed by the latitude and longitude. But if you want to add a particular building to the analysis, you find the building ID that you want. If you go here, you add it as a comma separated list, And you could also add a range of buildings by separating them with a dash. Let's say 1-10, comma 13, comma 17, and so on. You could select all the buildings you want to analyze that way. And then when you click on select, this table will grow or shrink according to the amount of buildings that you've selected. If you hit clear selection, then this table will show every single building you have in the database. So you can go through and figure out which ones you might want to add to the analysis going forward. Now, if you recall before in visualization pane, you had the ability to select the assets you want directly on the GIS map. Well, when you do that selection, those IDs for the assets that you select there will automatically be added to this list. And this will be kind of your master list or filter, if you will, of the asset IDs going forward for analysis, right? You can have 1 million buildings, but only analyze one of them if you want. Below that is the building information table. So everything in your CSV file gets recreated here again. And this allows you to edit a cell. So you could click here and you could change the number of stories. You could change the structure type if you want to see how that changes the analysis. You could change perhaps the year built to see how that will affect the damage and loss results. And anything you edit or change here gets reflected in the input file going forward downstream. So your original CSV file won't be touched, but a new CSV file will be created in the working directory of R2D with all that new information that you've added or edited here.
Steve, is this a good time to stop and ask some questions? Or would you like to continue a little bit longer? There's quite a few questions in the chat that maybe both have been answered. And so for those of you who are following along, if you aren't looking at the chat, feel free to post questions, but also we have some of the SimCenter team on board who are answering questions as we go along. But I'd like to maybe highlight a few of those. One question is, and this has been, I'll read a few that have been answered already, Steve, just so that these are recorded for posterity. Is R2D an open source software? And the answer there is yes, all of the SimCenter software is open source. It's available on our GitHub repo, which you can find through Googling or looking through the web page. Each of the tool web pages have links to the source code on GitHub. Another question is it possible to add a user-defined latitude and longitude to locate an asset of a particular asset? And the answer there is that not currently, unless you correct me, Steve, but it's easy enough to add. So if you have a feature that you think would be useful, please go to the SimCenter message board or the SimCenter forum that Steve shared earlier. You can post your feature requests there. Another question was, can you explain the input data requirements? What type of data are required and how to add them? And the response to that question is that you should be looking at the documentation for the input and file formats. The documentation is also at GitHub. You can find the documentation through the R2D tool. I believe it's up through the help menu. It's also posted on the tool webpage. So you can link from the SimCenter's webpage for R2D. You can quickly find the link to the documentation. There's another question that maybe we're not quite haven't gone over yet, but it's how can I modify the data? For example, if they want to use their own fragility curve, is that possible? We haven't gotten into the damage and loss portion just yet, Steve, so they might be ahead of you. Oh, you can't unmute yourself. I'm going to put you co-host, sorry.
Hey, sorry, yeah, I muted myself to have a drink. So yeah, that's coming later on in damage and loss, but we do have the ability to for sure enter your own fragility functions, but unfortunately you'll have to go into the backend to do that. But I could definitely show you where you can do that and how you can do that.
Okay, and then one last question before we let you get back. the asset definition for the buildings is not done automatically using Brails. And for just for clarification, Brails is another software developed at the SimCenter. It's for to create building inventories or to enhance building inventories through artificial intelligence. So that's the first part of the question. And the follow-up is that we need to define the assets manually. Is that correct, Steve?
Yes, currently you have to define the assets manually. And yeah, if you go, I believe there's another workshop, probably Frank or Matt, you know better than me, but I think there's a workshop on how you could do that, right? How you could set up these building inventories. Or if not, perhaps we'll do one in the future, but the idea is, yeah, there's certain ways you could do this by either scraping it off the web using text data. You can automate this, obviously. You don't have to sit here and type every building into that CSV file.
Okay. Thanks, Steve. We'll hold the rest of the questions for later.
Okay. So continuing on, this is where the location of an asset gets mapped to the hazard grid. So currently the nearest neighbor approach is used, and that's where the asset will find the n neighboring points. So if you can visualize how this works, is you'll have an asset sitting within a grid, and it will search that grid to find its n neighboring grid points, which you could adjust here. So number of neighbors. And the number of samples is how many samples are considered at each grid point. So say you have a grid point with 20 ground motions, you may only want to consider 5 of those. So you could adjust that here. And I apologize for my Canadian spelling of neighbor up here with the U. Going on, we have the local mapping. So here, here's where a specific event gets mapped to an asset. So this is still fairly rudimentary. Right now, we only support a SimCenter event, but the idea is you specify the event units and the event type, in this case, earthquake. But in the future, you can imagine there'll be something like a site response local event. So you'll have a global event, say like an earthquake, and you could get the rock ground motions. And then given the soil profile at a site, you can calculate the ground motions at the building level that are either attenuated or amplified, depending on your soil conditions. So there will be ability in the future to have these local events that, given a larger regional event, you can have these different local event apps that apply directly to your asset. So going on to building modeling, there are several building modeling options available. The really easy one is none. So if you don't want to skip building modeling altogether, you can consider only the intensity measures, like say PGA of your earthquake. And this is highlighted in examples 1 to 5. There's also the NDOF-LU and OpenSea's Pi, which I'm going to go through in the next slide. But NDOF-LU creates this little NDOF stick model in OpenSea's, and examples 2 and 3, you will find where that's used. And OpenSea's Pi script generator does something similar, but it does so through an OpenSea's Pi script that you as a user can manually modify yourself. And this is highlighted in example 4. Now, when I show the demo after this presentation, I will go over this script file to show you how you can do something similar yourself and use it as a starting template. So NDOF-LU generates an idealized structural analysis model based on the structure type, the height, plan area, the year of construction, and occupancy. So essentially, NDOF-LU employs building configurations it has this and corresponding capacity curve to define a multi-story nonlinear shear column model with lump masses. So this is your structure, and this is your idealized NDOF shear column model, and you lump the floor masses at each point here in the NDOF model. So shown here at the top, the user needs to specify the HAZES data file. I'd recommend you use the one that's shipped with the examples. And what that HAZES data file does is it contains the parameters for different building types that are used to generate these NDOF structural models. So depending on the type of building, other input parameters I mentioned previously, the year of construction, all that's sitting in this HAZUS data file. And that comes from the MDOF-LU research group, and it will automatically generate this model in the backend. Now, as a user, what you can do is you could enter the standard deviation for the stiffness and damping, which are random variables in the backend there. And you could also enter a default story height if you wish. I get 3 meters is what gets set by default, I believe. This is a real interesting one. So similar to the MDOF-LU, here we create also an MDOF stick model, but this is done using a Python script. So the user has to create this Python script outside of R2D. Again, example 4 has an example of how this is done, so you can start from there. And you just have to point R2D to the location of that script. You could also do your own custom DOF mapping. So by default, the workflow assumes that X equals 1. The X direction is 1, Y direction is 2, and Z direction is 3 between the degrees of freedom, with X and Y being the horizontal directions and Z being vertical. But the input allows you to define an alternative mapping such as 1, 3, 2, if you wish to have, say, Y as the vertical direction. So that's what this DOF mapping input is used for. And then below that, you enter the analysis spatial dimensions. So do you want to run a 2D or 3D analysis? And also the number of nodal DOFs, like say 6, for example. And again, as part of the demonstration, I'm going to go through this file here to give you an idea of what's expected. Now, both in the MDOF-LU and in this OpenSea's Pi script generator, these files not only have the structural model, but they also have the analysis input file. So in the future, we're probably going to split those up, but right now the analysis is bundled with those, or gets created, I should say, with the MDOF-LU for OpenSea's and the OpenSea's Pi script generator for OpenSea's Pi. So here, all you have to do is, depending on which modeling you use, you select that type of analysis engine. So if you're using MDOF-LU, examples 2 and 3, you're going to select OpenSea's. If you're running example 4, OpenSea's Pi, here you want to select OpenSea's Pi as your analysis engine. Now, if you have no building modeling, you're going to select IM as EDP, which, as the name suggests, it just takes an intensity measure, IM, and it passes it through directly as, as if it was an engineering demand parameter, EDP. And this is highlighted in examples 1 and 5. Now, currently for damage and loss, Pelican is employed, which is developed here at the SimCenter. Now, Pelican stands for probabilistic estimation of losses, injuries, and community resilience under natural disasters, sorry. If you want more information on Pelican, you can go to the SimCenter website or access this link right here. The available damage and loss methods are all HAZUS-based currently, and they are HAZUS MHEQ, HAZUS MHEQ IM, and HAZUS MHHU, which is coming soon. The HAZUS MHEQ, it expects the inputs to include standard EDPs for earthquakes, such as peak interstory drift ratio, peak floor acceleration, peak roof drift, peak floor displacement, that sort of thing. The HAZUS MHEQ IM, only intensity measures are considered. So if you have no structural model, this is the one you want to use. So this approach is, of course, more rudimentary. It only expects an intensity measure, PGA, and you want to use this when there's, again, no structural model. When you have a structural model, you'll want to use HAZUS MHEQ if you do any sort of building modeling. And again, this third option is coming soon, and this applies to the HAZUS methodology, but for hurricanes. I won't go too much into detail about that. So in the Pelican input pane, the user should select the appropriate damage and loss methodology at the very top here. And as we discussed previously, depending on the type of analysis, you want to select the appropriate DL method. Below that, the user can specify if they want the event time on or off. This doesn't do too much now, but selecting off turns all time effects off. So the number of realizations is the number of loss realizations to generate in your analysis. If you want to output detailed results, you'll check this checkbox here. And what detailed results mean is Pelican outputs detailed intermediate calculations of each building. So if you ever run PBE before, another app here at the SimCenter, it will output exactly what the PBE app does. But you can imagine, be wary when you check this because you have tens of thousands of buildings. You'll have gigabytes of data at the end of the day. So next, you can create a Pelican log file if you want to see what's going on behind the scenes, kind of at a higher level. You'll check this, and in your output folder, you'll see there will be Pelican log files sitting there. When using structural models, it could be important to couple the EDP to the loss analysis. And this is to preserve spatial correlation. That means for each EDP calculation, a subsequent loss analysis will be conducted. Now there's another approach where you could decouple the EDPs. In that case, distribution gets fit to a small number of EDP realizations. And then in your damage and loss analysis, you could sample from that distribution many times. Right? But for the most case, you'll want one EDP to be, I guess, transferred forward and used in your damage and loss calculation. So you'll want to couple them. Lastly, there's the option to include ground failure. So in this case, vertical and horizontal ground displacement, or PGD, is required as an additional input to the damage and loss calculation. And if you want to know how that works, please see example 5, ground shaking and liquefaction, to see how you can include ground failure as well into your damage and loss calculation. So you can have your structural response and then include ground failure as well. So in terms of uncertainty quantification, or UQ, R2D currently uses Dakota as a UQ engine. This is essentially an orchestrating algorithm. And it was created at the Sandia National Laboratories, specifically for uncertainty quantification. But coming soon, the SimCenter is also currently developing an in-house suite of UQ methods that will include sensitivity analysis and surrogate modeling. Now you can expect at the regional scale, where you have enormous amounts of data, it'll be beneficial to know what data is important, what you need to get right. And what data is not so important, it's okay to maybe ballpark it. You don't have to spend too much time getting that data right. So that's where sensitivity analysis will come in and be important. Also, as these response models become more and more complex, you can expect computational time to increase as well. And these surrogate models, they can eventually replace these complex finite element models, and they could be evaluated at a fraction of the time. Now, the caveat here is the surrogate model must be a good representation of what your actual finite element model is. Right? So with good enough surrogate methods, we could create these surrogate models and run these regional analyses many, many times to get a better description of the losses in a region. So in the Dakota UQ, Pane, I should say, the current UQ methods that are supported are Latin hypercube sampling, or LHS, and also Monte Carlo sampling. If you select the other options, it won't work. And below that, you simply enter the number of samples you want and the sampling seed if you wish. So both for LHS and Monte Carlo, you have a similar input panel like this. And you could check this box if you want to keep or discard any of the samples. And what that means is every time you run a sample, you can store the output in your output folder. If you have a low number of samples, that's good. But once you have thousands and tens of thousands, you can also get a lot of data accumulating. So in the event that a model contains user editable random variables, this is where they will appear. And note that none of the current examples contain these, or yet contain these user-defined random variables. But the idea is that a user can implement their own random variable in one of their building model generation scripts, say. And the instructions for defining and using these random variables in the workflow are in the documentation. I won't dive into it here. But essentially, the random variable has to follow a specific naming convention. so that Dakota will recognize it and know how to do the sampling on it. And moreover, if you define it somewhere in your script, you'll have to define it here. So here you define the type of distribution, and the distribution parameters. Let's say if you have normal distribution, the mean, and standard deviation. And you could always click on the Show PDF button to plot the probability distribution function of the random variable you just created, and that'll appear in this new dialog. So in the next few slides, I'm going to concentrate on how you could run analysis locally and remotely in R2D. And to run a local analysis, it should be fairly simple. You can go into the examples menu, pick any example, load it, and at the end of the day, it'll say click run. And all you gotta do is click this run button here. And it'll take some time. You'll see the output from the backend get piped to this status dialog. And at the end of the day, it will say analysis complete, and the results pane will automatically appear. And of course, depending on the number of assets you have, how many sampling iterations you have, it could take a long time to run locally. So that's why running these things remotely is beneficial. So running an analysis remotely is almost just as easy, but the user needs to have a free Design Safe account. So go to Design Safe, set up your account. First step is to click on this login button in the top right. You'll see this dialog appear where you enter your username, your password, and then you click on login. And in the status pane, you'll see it'll contact Design Safe, it'll create your remote directory on Design Safe, and it'll say login success. So once you do that, you could set up your analysis or your example. You could, to test this out, say run example 4, and then you click on, or load example 4, and then you click on the run at Design Safe button here at the bottom, and that will make this dialog window pop up. And here the user has to give the job name and fill in some parameters that control how the analysis is run at Design Safe. For example, how many compute nodes do you want to use? Or in other words, how many cores on the Design Safe cluster? How many processes or threads per node? I think 64 is the maximum, but if I'm wrong, Frank could chime in. This is the number of buildings per thread or per task. So here, let's say we have 64 threads, 10 buildings per thread running in parallel. You could analyze 640 buildings at once. And here you could save intermediate results. If you click this checkbox, and at the bottom, you want to set the maximum runtime. So for a small example, like example 4, you can just put 20 minutes. If it's something more involved, you can add a few hours. Now, the more nodes you want, the longer this job might stay in queue. Right? You can't take over the whole computer. So there probably is a limit too. I don't know off the top of my head. Maybe Frank could chime in at the end. But the idea is here you set up your analysis to run remotely, and you click on the submit button. And that's it. You'll see that it'll contact Design Safe to create your directory for this job. It'll upload the input file. It'll upload the directory. So what happens is all of the building databases, the ground motion files, they all get saved in an input directory. And that'll get zipped up, bundled up, and sent off to Design Safe, where it gets extracted over there and run on the back end. And also the input file. So in theory, you could take this input file and also run it on your computer as well. It'll say job successfully started, but unfortunately it doesn't mean the job is actually started. This just means it's successfully submitted at Design Safe. And what you want to do is click on the Get from Design Safe button at the bottom to see the status and to download the results. So the last step here is you click Get from Design Safe. And when you do that, the Remote Job Manager dialog will appear, as you see here. And at this point, you should see that the job is in the queue, which is shown on the left. Sorry, I gotta take a sip of water. Now you could right click on that job and it'll show you several options like refresh job, retrieve data, delete job. You can delete your job and data. And depending on how busy DesignSafe is, now might be a good time to go get a sandwich because it could be in the queue for a while. You could always come back at any point. You could close R2D, open it up again, log in, click on the Get from DesignSafe button, and the same dialog will appear, and the status of your job will show. And you could also refresh it at any time from the program. You'll see here that the job is currently running now, and this is a small one, example 4. And when everything is done, it'll say finished. So the last step here is to right click on it and click on retrieve data. And depending on the size of your analysis, how many assets, what your output settings are, if you want to output every realization or if you want to have Pelican provide intermediate results, this might take a while. The data file could be very large. So you click on retrieve data and you might want to get a second sandwich if you have a really large job, it could take some time. So whether it's a local job or a remote job, you'll still see the same results pane. So everything will get loaded automatically into R2D, and you'll see this GIS pane pop up, which is some other docs on the side. And what you can do now is you can select any asset within this GIS screen, and this pop-up will appear showing the different parameters of that asset. So if you go back into the asset definition or that CSV input file, each column stands for a different parameter, like say occupancy, class, plan area. And when you click on an asset, whatever values are in those cells will appear here again. And you also see a loss ratio. So this comes from Pelican. On the right-hand side, you have a summary doc of the region. So you see this region was hit by the fist of God, so there's a lot of damage. But you also have below that different docs, like for example, the relative frequency diagram of the losses in the region, economic losses split up according to damage states. You have casualties according to the severity levels. And then you have a detailed results table where you have the asset ID, the repair cost, repair time, replacement probability, fatalities, and it's hard to see, but this is loss ratio. And you could sort this table according to any one of these columns here to see which assets take perhaps the longest to repair or cost the most to repair, which are most dangerous to human health. And you could also export all of this to a PDF. So you could enter whatever folder you want this to go in or the name here, click on export to PDF, and it will create a PDF file of these results. Now beware, if you have 100,000 buildings, this file is going to be very large because this results table will be occupied tens of pages. So just beware when you do that. Aside from the graphical representation of the results, you could see the raw files as well. So going back to the SimCenter preferences and the menu there, if you remember, there's this local directories part of that preferences dialog. And here is where you could find where your results are going to be saved. So my local jobs are saved in my local work there by default in documents R2D, and remote jobs are in documents R2D remote work there. And this is how that looks on my Mac here. So if I click on remote work there, this is the temp.simcenter folder where the input data gets assembled, the input file appears, and where the results will be. Now note that this folder will be cleaned every time a new analysis is run. So say you run an analysis, do you like the results? Well, you better copy and paste what's in this folder somewhere else in your computer, because if you go back and run another analysis, it's going to be overwritten. And from Pelican, you have individual folders for each building. And the name of this folder corresponds to the building ID. So this is building 18, building 417. And if you enter these folders, you'll see all the different files from the analyses and from each run. And you also see the DM, DV, and EDP files from Pelican for this specific building. Now, if I go up into the results folder, so back up here, you'll have a summary. So this is what R2D imports, DV 18 to 435. That doesn't mean there's 400 something odd buildings here. It's just the range of buildings. So if you see here, there's 10 buildings, but the ID ranges from 18 to 435. So this is what R2D loads at the end of the day, which is a summary of every single building that was analyzed. And furthermore, in this results folder, you'll also find the log file. So if anything happens in the analysis, it fails, or R2D crashes at some point, you can go into this results folder and you'll find a log file. And if you want to report a bug, it's also beneficial to send us this log file. And here it has more detailed information of what's going on in R2D. And some of it may not be understandable to you because it could be for developer knowledge and use, but it's a good resource to see if something went wrong. Yeah, before I forget anything, like I said, things will get clobbered in this temp.simcenter folder if you want to run a new analysis. So if you're happy, you can save this somewhere else and then go back into the results menu, load results, and load them again. You don't have to run the analysis over and over. This is how that CSV file looks. So this is the summary CSV file. Here you see the different building IDs. And at the top here, you have headers for each column. And this is the legend of what each one of these headers stands for. So DV is, of course, decision variable. So from Pelican, you have the repair cost, the repair time. Comp type means component type. So is it a structural component, non-structural, not shown here. Then you have DS, or DSG, DS, which is damage state group, damage state, damage state 1, 2, 3, 4. And then you have statistics. So stat means statistics of each DV output. So you can get the mean of the repair cost, right, for each, depending on how many DL realizations you have. You get the mean, standard deviation, and then some other descriptive statistics as well. And you also get the repair impractical probability. So what is the probability that the repair is impractical on this building and it'll have to be replaced instead of repaired? So now I'm going to shift to the demonstration. I'm going to close the presentation here. And I don't know if there's any questions, Matt, if you want to do a question session now.
Quite a few questions, Steve. We might need to get another drink of water. We will get to these as best we can. So there are quite a few. It'll be difficult maybe to triage them, but I'll do the best I can. One question is, what is involved in bringing in a shake map of PGA from USGS into R2D? Is that something they would need to convert? Is that something that would work in R2D?
Yeah, so it's not in the version of R2D you have now, but it's coming very soon. So all you would have to do is create a folder somewhere on your computer, and you'd add a shake map grid file. Say if you want to visualize things, you could add the PGA contours, and then automatically R2D will take that grid file and create a SimCenter event that you could use for analysis going forward. So it's going to be very simple to import shake maps. We just haven't gotten there quite yet, but it's very close.
Also on the hazard side, but flipping over to hurricanes, can we implement and use synthetic hurricanes, say a set of predefined tracks?
Yes, you can. So the track, I believe, is just in a list of latitudes and longitudes. And then the hurricane input file, you'll have the landing parameters, essentially what the wind speed, and radius, and so on. So sure, you can create a set of synthetic tracks, just the same way I imported that track, if you recall the first time. I mean, I'll show it in the demonstration again, but you can create a synthetic track and run it in R2D for sure.
Now, if they want to run a large number of those tracks, or what would be the maybe best practice, or is it possible to run thousands or tens of thousands of tracks?
Yeah, not currently. I mean, that feature request, if you go to the R2D forum, but I don't see why not. Yeah, it could be done, but just it's not currently capable of doing that.
Let's talk briefly about assets and then go over to EDPs. Can you filter directly in the Assets Selection tab by things like occupancy type?
No, you currently can't, but I could create that functionality similar as you saw in the results where I filter according to the columns. I could implement that drop down where you select a header and filter according to that header.
Okay, 2 more quick questions, then we'll get to the demo. What input engineering demand parameters do you consider for loss assessments in Pelican?
So Pelican can take a few different types of EDPs. It's best to go to the documentation, but I think it takes, let's say, peak interstory drift, peak floor acceleration, peak roof drift. There's probably some other ones I'm missing right now, but you do have quite a bit of options there. But yeah, I'll direct you to the Pelican documentation to see exactly which ones.
Okay. One more question on Pelican, which I know. So Pelican, the question is, how is community resilience calculated in Pelican? And is there use of recovery models or resilience indices?
Yeah, so currently there is no recovery models built into Pelican. I think we stop at repair time, repair cost. That is a future thrust of research that we are looking at for R2D. So not yet, but that is definitely on the horizon.
Thank you, Steve. And I see 10 new questions. So we're going to stop with questions for now. Let you do the demo with the a little over half hour we have left.
Okay. So I'm going to bring up R2D here. So when you open R2D, this is what you will see. I'm going to quickly go through the menu. So we have, again, preferences. This is how that looks. I currently have this set to my version of Python, but the Mac users will have to add their own Python there. And before I start stepping through these different panes, I'm just going to load an example. So here I have example 4, but let's say I want to download some other examples. I will do that now. I'll just download 1 and 3, click update, and it's going to take a few seconds, but it's contacting the server, downloading the examples, and within a few seconds here, they should be installed. And once I have these examples downloaded, I will load one of them and I'm going to go through each one of these panes quickly again. So now all example downloads are finished and it says go to examples menu to load an example. I go back up here and now I see the new examples that I downloaded. And let's say I want, perhaps I'll load this one. This one has over 15,000 buildings, almost 16,000. So first it's going to load the assets, then it's going to load the hazards. It's going to go through this list and load everything. And it's almost done here. And now it says done loading, click on run to run analysis. So this is how that looks. These are the, up in the legend, when I click on a certain layer, it'll tell me the building footprint. So I'm looking at buildings here. If I go to the selected objects, it'll show me which buildings are selected. Right now I haven't run anything, so there are going to be 0 loss ratio. I could turn off the buildings layer to see only the buildings that I selected. I could click on any buildings and all the information that's in this asset definition pane will appear here. Just to quickly show you, so these headers, if I go back here, appear when I select one of these components. And finally, the user ground motions are here as well in these grid points. I also have the capability to rearrange these layers. So let's say I want to make the building layer come out on top. Now the building layer is on top, and I could also adjust the opacity of each one of these layers. Let's say I don't, for creating figures or something like that, I could reduce the opacity. I could set the base map to imagery. And you have different options to create figures. You could select, highlight a particular building. Oh, this highlighted the entire imagery. But yeah, the idea is you can select on each building and get a pop-up. And sometimes there's more than one building at a particular footprint location. Okay, moving, what else? Oh yes, this is an important one. So you have the ability to select, and quickly go back here and put things back how they were. You have the ability, as I mentioned, to select buildings directly in the GIS pane, and that works like this. Let's say I want to select or to add these buildings here for analysis. I can do that by defining this polygon, and I want to click on apply. You'll see that these buildings were added to the selected objects layer. So it allows you to be pretty specific in which buildings you want to add to the analysis. You could do whole cities or city blocks. Moving on, we have the general information layer. This is pretty straightforward. I won't spend a lot of time here, but you have different asset types. When you click here, if I go back here, then the different asset types will appear here. If I turn it off, then only the current available option appears. So I'm going to spend some time here once I go through this and show you how you could quickly run an earthquake scenario simulation, but I'll come back to that. And also on the hurricanes. Here I won't spend a lot of time, but as I mentioned previously, when you select these buildings in that GIS pane, they get added here to this list. And of course I could clear everything here. And now this, this layer should clear. Moving onwards, I have hazard to local asset event. I won't spend a lot of time here, but only at nearest neighbor. Building modeling in this example is none. Analysis is we're just pushing our IM forward as an EDP. Damage and loss application is Pelican. Since we only have IM, we want HAZIS MHEQ IM. We have no UQ in this place. Everything is getting, in this case, sorry, everything is getting taken care of by Pelican. And if you run everything, the results will appear here. But I'm going to clear this. I don't know why it's not clearing for some reason, but I'm going to bring R2D up again here. If I, let's say, load example 4, remove the ground motions. Okay, now I just have my building assets here. So I'm going to go into hazard, and I'm going to go to earthquake scenario simulation. I'm going to leave everything as it is, and then I'm going to click on define grid on map. And now this lets me zoom in and out. I could adjust the grid. I could go back here and just close this. I'll say I want 20 divisions and maybe 15. If I go back here, the grid will automatically change, and I could move the grid around and really position it where I want it so it has optimal coverage of my assets. And when I close that, I can go to the settings, see where everything is going to be, where all the input and output files are going to be. And I could click run. And it's going to, take some time, and we won't wait for it to finish. But it's going to run everything in the back end now and download these ground motions from up here. And at the end of the day, you'll see a grid appear. Maybe I'll load R2D again and go back here to highlight some of the hurricane functionality. Let's say I go to let's do the hurricane scenario simulation. So this is where I specify that hurricane track. I'm going to go to my desktop, hurricane example, and I'm going to load this really big track that starts down here in the Caribbean Sea and ends up here in Atlantic City. But there's a lot of data here, so I'm going to truncate this track. So I'm going to use these points to make the analysis go a little quicker. And I want to define the landfall on the map. I could do that by zooming in. Let's say I want it to be here. I select landfall. The user also has an option to import a terrain.geojson. So this is a JSON file showing the terrain roughness of different, say this polygon, here's the terrain roughness of this one, of this one. And of course, if I had a bunch of assets loaded here, now we could define where this wind field grid will be created. We could have a lot of divisions here. And then I click on select grid, and I think now I have everything I need to run a hurricane scenario simulation. I'll click run here. And you'll notice just some default parameters are currently listed here for landfall. Of course, you could edit these and also add these in the input file so they automatically get loaded up here. But given all that, you click on run. At each one of these points, it will calculate the peak wind speeds. Right now it's NA because I haven't run the backend, but this will be updated. And depending on how many peak wind speed realizations you want, that many peak wind speeds will appear here. I'm going to clear this and go back to hazard. And this time I'm going to select it from the database. So I'm going to load the NOAA hurricane database. I'll take a few seconds. But now every hurricane in the last 3 years will appear here, and you can zoom in on any particular location that's of interest. Let's say down here. Pick this one, it's Hurricane Gordon in 2018. This one, doesn't matter, you could pick which one you want. See this, see the Lake Charles here. I think this is Hurricane Laura, yeah. I could select that hurricane and it automatically creates a track. Now you'll notice the landfall burst appears here, but we want to run the calculations up here. So we're just going to go back here, clear the landfall, and define a new landfall. And once we have that, we could create another grid. And I select the grid, and you'll get, after you click run, and depending on the number of wind speeds you want per site, this grid will of course get populated. And we push forward onwards for analysis. So I'm going to clear everything again, and I'm going to load example 4 to give you an idea of how an example is run. This looks like I have a little bit of internet connection buffering problem. So yeah, what happens is these tiles are downloaded from the NHERI server. I'll reload this. And probably using Zoom, my internet connection isn't the best. Here we go. There we go. Okay, now that I have example 4 loaded, I should be able to just click run. And now it says starting the analysis. This may take a little while. And we just wait. This analysis should be fairly quick. But this is the one running the OpenSea's Pi script, which I'll go over in right after this is done. But the idea is for each one of these buildings in the region, it's creating an MDOF model. It's picking ground motions from these neighboring grid points, and it's running the structural response, sending those EDPs forward to do the final damage and loss assessment. I think there's only 3 samples to get created here. It shouldn't be too much longer. But of course, Zoom is a processor hog, so it might take a little longer now. And at every point, you'll see the output from Pelican. So these are the commands that are being called. You could technically copy and paste this and run it in your terminal if you want to run the backend. And that's okay, analysis complete, so everything's done. I'm going to close this, and then you'll have a estimated regional total. So there's no building replacement values here. These are just a loss ratio, so the repair cost will be equal to the loss ratio. In other words, the building replacement is 1. Here's a relative frequency diagram, different economic losses, casualties. So it's very low, it's very mild. And of course, you can go export to PDF, and it will create a results PDF that looks like this, and it just provides that result summary. Whatever visualization you have here will appear here, and then the different charts. And of course, there's only, I think, 5 buildings here, so your relative frequency diagram doesn't look all that special. But if you have a region, it could provide just a high-level summary of the results. And you could always go into your R2D local work there, temp results, and you'll have everything sitting here. Okay, so we have some time left. I'm going to close everything here, and I'm going to focus a bit on that Python script for generating these structural models and also for the analysis. So as I mentioned previously, both the model generation, so build model, and the structural analysis are set up in this file. So what this does is it generates an OpenSea's Pi model of an elastic, perfectly plastic structural system, NDF system that runs a gravity analysis. And then these are the input parameters. We have some units here, and we'll go to that, but the input parameters are a number of stories, the type of structure, one of the HAZs structure classes like S1, C1, and also the plan area of the structure's footprint. So we have some assumptions here for the weight and height. Of course, these could go into your input file as well, or your database, and then you call that, get that from there. See here, we're asking for the number of stories from the model. Approximate the fundamental period. Depending on the structural type, you have different parameter values. And here's where we estimate fundamental period, just a unit conversion. Then we calculate the lump mass on each floor. We calculate the stiffness. We set some basic model materials, settings, the linear time series, and then for each story, we define the nodes, the fixities, and the different elements. In this case, it's a 2-node link with lumped masses. And then we run a gravity analysis. And finally, at the end of the day, this is where the dynamic analysis is run. So in R2D, for each building, it's going to run a dynamic analysis. And these are the different input parameters, like time step, the number of points in the time series, and the time series list. So what EDP specs are coming out of here, I'll focus more on that. This is just setting up how the time series and analysis is run. So I'm going to skip ahead. So here we have the PID, so peak industry drift is one of the EDPs. And another one, peak floor acceleration in both X and Y direction. And that EDP envelope dictionary then gets sent forward to Pelican, which calculates the damage and losses. So this gives you a rough idea of how you can go into this file, adjust, say, the material, the type of structure, the stiffness, to play around to see how that affects your regional damage and loss. So this really gives you a template, and it's pretty powerful. I mean, you can get as complicated as you want and have many types of rule sets or filters to create your structural model based on whatever inputs you have in your building inventory database. So save that. I will now go back to the presentation, and I hope everyone enjoyed the presentation, and perhaps you have some ideas on how you want to contribute to R2D or use it in your research. And we're of course excited to collaborate with you. And again, if you have any feature requests or problems questions after today's presentation, please go to the SimCenter forum and ask your question there, and hopefully it'll be answered within a short amount of time. And if anyone has a similar question, they could hopefully find the answer there and solve the problem quickly. Thank you.
Thanks, Steve, for the presentation. We have lots of questions still. While we gear up for the questions, I am going to send a quick poll. I'd appreciate it if you answer these 3 brief questions. The first one is, have you interacted with the R2D tool yet? And by that, I'm just curious if you've bothered to download the tool before today's training, or if maybe during the training you've been intrigued and downloaded it. And then the next question is, how satisfied are you with the training today? And the last one is, how likely is it that you will use R2D in your research or work? So if you'd answer those questions, I'll leave that poll open while we get to some of the questions you've had in the chat. Also in the chat is the link to the message board, the SimCenter forum. So you can post your feature requests, you can post your questions, things that you've encountered that aren't working. If, for example, we don't get to your question here today, posting it there in the SimCenter forum is really helpful. We'll get the question answered there. So Steve, one question is, will you make any examples for the hurricane scenarios in Texas or Florida?
I don't know about Texas or Florida. I think Louisiana, the Lake Charles testbed is one we're working on, which should come down the pipeline pretty quick. But yeah, I mean, if someone wants to help out, or if they have, like, say, building inventory or some wind field models, we can easily set up an example somewhere else, like maybe Galveston would probably be a good one. I know some other research groups out there focus on that test bed.
Okay, and then are you planning to have any infrastructure network, for example, electricity, available in the simulations?
Yes, so that's definitely in the pipeline. I work on another project called OpenSRA with the California Energy Commission, and we focus on natural gas infrastructure. So the idea is to expand R2D to include those lifeline networks such as electricity, natural gas, perhaps roads, that sort of thing.
And right. And so then another follow-up question to that was on wastewater networks. So I guess that's probably similar to the gas networks. All of those come with, a bit more of concern around publicly data becoming available publicly and privacy, but more about security concerns. I'm not sure that we've fully figured out how we release information, but I guess the idea would be that the capabilities to import networks, realistic or not, would be available, right?
Yeah, exactly. So the networks might not be realistic, of course, according to NDA and stuff like that. Mm-hmm. But you should be able to take your own private data set and put it in there and get results.
Okay, and then I think there are a few questions about the MDOF-LU model, and maybe, I guess, also related to the OpenSea's Pi script. So the OpenSea's Pi script is available, is that correct?
Correct, yeah. If you download example 4, I don't know if I mentioned this, but in the R2D directory, wherever you install it, when you download an example, there will be an examples folder, and within that examples folder will be individual folders for each example. Now, if you go and download and install example 4, you go into the example 4 folder, you will find that script sitting there and access it, play around with it and modify it, and run it.
Okay, the next question, are there distinct building performance models to run Pelican loss assessments for each asset? So I think that's asking whether there are models that include structural and non-structural components already described so that they're loaded out of the box, I think is the question.
Yes, yeah. So structural and non-structural components are available right now in Pelican for the buildings. And of course, it's all based on hazards data. But yeah, no.
And while we're talking about HAZUS data, is there debris quantity and type output available similar to HAZUS MH? So I think they're talking about maybe the amount of debris created in for a particular outcome.
Maybe damage quantities or repair quantities,
so.
perhaps. I'm not sure. That's a good question. I will have to dig deeper into PBE to see if that's easily available.
The response there is to enter it into the SimCenter forum as a feature request if they don't see it, right?
Correct, yeah.
Fantastic. And then I guess one other question is, what algorithm is used for the nearest neighbor approach? This is going back to the hazard descriptions.
Yeah, so that's also a good question. So it's a Python package. I want to say it's SK toolkit, but I'm not 100% sure. I could definitely answer that for you, but I don't know off the top of my head. I know where to find the answer. It's a readily available Python package, put it that way, that uses, I think maybe the SK search algorithm, but that could be wrong. I'm not sure.
Okay. There is one more question in the chat. Are the tools available through DesignSafe or just the SimCenter? So I think what we would like to do is just clarify the roles of SimCenter and DesignSafe, because sometimes because we're partners within the Niri organization, the lines of distinction blur a little bit. And so for clarification, SimCenter is a separate entity from DesignSafe. DesignSafe has an award to provide the cyber infrastructure, the supercomputer, the website, the ways we're communicating, such as the resources like the SimCenter forum, and that they're providing that for all of the Niri sites. SimCenter is a separate award, and we're providing software like that we've demonstrated today. Our software will run locally on your computer. It will also run at the supercomputers at DesignSafe. And once again, DesignSafe is located at the Texas Advanced Computing Center. So I think that covers just about all of the questions that we've had in the chat. I do want to mention that we also have office hours with the SimCenter development team. These are every other week, and fortunately we have office hours today. I'm getting my reminder that it occurs in just 9 minutes. I'll put the Zoom meeting information in the chat if you care to join us to continue this discussion. But at this point, Steve, we're going to conclude today's tool training. I want to thank you for the presentation. I want to thank the development team who's been answering questions in the chat as we go along. And then for all of you in attendance, we appreciate your questions and your interest. Please reach out, let us know what features need to be added to the tool and how we can continue to improve.